Welcome to Creative World. In this video, we will solve a problem related to delta to star conversion in resistive networks. Solution of this problem is requested by Jitin through email. So here is the email from Jitin in which he requested for the solution of two problems. One is related to superposition theorem and other one is related to equivalent resistance. So first of all, I will thank Jitin for his worthy feedback. Secondly, I can show you the problem which he requested related to superposition theorem. So without wasting time, we will go back to the problem and solve it. While solving this problem, we will be using delta to star conversion formulas that are listed here. We know that in order to convert any delta connection into star connection, so we have to follow these three formulas. Ra of star connection will be equal to the product of these two resistances divided by the sum of all resistances in delta connection. Similarly, formulas for Rb and Rc of star connection are given here. Now move towards the problem. The statement of problem is: suppose a resistive network is constructed as shown below, where each of 5 resistors has the same unknown value of R. Find Rab, the resistance between the open terminals A and B. Provide your answer as a mathematical expression in terms of unknown R. So this is the circuit diagram of given problem. Inside this network, no resistance value is specified. We have to take all resistances as R and all of these resistances are same. These two key points are given in this scenario. So first of all, in order to solve this problem, if we observe, this is a delta connection. In order to find the equivalent resistance of this network, we have to convert this delta connection into star connection by placing a star connection inside this delta connection, and we will use these three equations to find equivalent resistances in star connection of this delta connection. Ra will be equal to the product of R1 and R2 divided by the sum of these three resistances. So first of all, we will try to find out Ra. Ra is equal to the product of R1 and R2, and both of these resistances are equal to R divided by the sum of these three resistances which are also equal to R. Take the product of both R's, it will become R square divided by the sum of these three R will be equal to 3R. Now the square of this R will cancel out with R in denominator. Only R divided by 3 will left. Here another theory is also proved. If we have three same resistances in delta connection, so their equivalent resistance in star connection will be equal to the resistance of a single branch divided by 3. Now because the values of delta connected resistances are same, so their respective values in star connection Rb and Rc will also be equal to Ra. We have calculated equivalent resistances in star connection of this delta connection. Now we can replace this delta connection with star connection completely. Delta connection is replaced with star connection. At this stage, these two resistances and these two resistances are converted into series connection. So we can find their equivalent resistance by adding the values of these two resistances together. R divided by 3 plus R will be equal to R equivalent of this branch. Take the sum of R divided by 3 and R, it will become R plus 3R divided by 3, and add 3R and R, it will become 4R divided by 3. Now the value of equivalent resistance of this branch will also be same because it also have R divided by 3 and R connected in series connection. So modify the circuit diagram. Now we have two parallel connected resistances having same value of 4R divided by 3. In order to calculate their equivalent resistance, we will use parallel equivalent resistance calculation formula for same parallel connected resistances. In that formula, we divide the value of a single resistance by the number of parallel connected resistances. In this case, the value of a single resistance is 4R divided by 3, while the same parallel connected resistances are 2. So 4R divided by 3 divided by 2. It will be equal to the equivalent resistance of this parallel connection. Solve this equation. Denominator value will be multiplied with 3. The equation will become 4R divided by 6. Update this circuit diagram by replacing these two parallel connected resistances with their equivalent resistance 4R divided by 6. Now at this stage, these two resistances are converted into series connection. So in order to calculate the value between these 2 points, we will add these resistances together. RAB will be equal to the sum of R divided by 3 plus 4R divided by 6. Take the LCM and solve this equation. It will become 2R plus 4R divided by 6. Now add 2R and 4R together, it will become 6R. 6 in numerator will cancel out with denominator, only R will left. So the value of RAB inside this network is equal to R ohm. Whatever the value of R will be, that R will be equal to the equivalent resistance of this network. So this was the solution of second problem requested me through email from Jitin. Thank you. See you again in next video.